Okay, now let's see this question. This question came in GATE 2011 for 2 marks. In fact, it is a linked answer question, so both of these are 2 marks each, so overall 4 marks are there. Now let's consider the question. An undirected graph G, V, E contains n, where n is greater than 2, n nodes named V1 through Vn. Okay, 2 nodes Vi and Vj, they are connected if and only if this condition is given, that modulus of I minus j is greater than 0 and less than equal to 2, which means that modulus of I minus j, either it is 1 or 2. Okay, then only the vertices Vi and Vj are connected. Okay, after that they are saying that each edge Vi, Vj is assigned a weight I plus j. A sample graph with n is equal to 4 is given below. Okay, so let's understand how this graph is constructed using the rules given above. So V1, V2, V3 and V4, these are the 4 vertices. Okay, now see, V1 will be connected to which other vertices, that is defined here, that only if I minus j modulus is either equal to 1 or 2, then only the edge exists, which means that it can be connected to 2 or 3. Okay, why? Because in this case 2 minus 1 mod is 1 and here 3 minus 1 mod is 2. So the modulus I minus j, this thing is coming out to be either 1 or 2, and that's why these connections are there. And what is the weight of this edge? The weight is given by I plus j. So in this case the weight is going to be 1 plus 2, which is 3, and in this case 3 plus 1, 4. Okay, so you see here also, right? So V1 is connected to V2 and the edge weight is 3, and V1 is connected to V3, edge weight is 4. Similarly, you can construct other edges. So V2 will be connected to V3 and V4. Okay, because modulus has to be either 1 or 2. So in that case 3 plus 2, this edge is 5, 4 plus 2, this edge is 6, and then we go to V3. V3 is connected to V4 and there is no V5, that's why only this connection exists. Okay, and this edge is 7. So you see that this is the exact same graph which they have given in an example. Okay, now they are generalizing the concept and they are saying that what will be the cost of the minimum spanning tree, MST, of such a graph with n nodes. Okay, so firstly consider that what is going to be MST in this case. So if we try to use Kruskal's algorithm, then how this will turn out, let's see. So V1, V2, V3, V4, these vertices are there. Now the smallest edge here is this one, right? This one, right? Okay, now after that this is connected to this also. This will also be in spanning tree because 4 is the second smallest edge. Now after that 5 cannot exist because it is going to form loop. Okay, so 3 and 4, these edge weights will be there. 5 cannot be there because it is going to form a loop. Let's come back to 6. Now 6 is possible. Okay, 6 is possible. Okay, so this is the way in which it is constructed. So this is the spanning tree here with n nodes, with 4 nodes in fact. Now we have to generalize it for n nodes. So for that we have to better understand that how this, what is the pattern in which it is going to this MST is occurring. For that we are going to take an example which is going to be slightly bigger. So let's consider 6 vertices, something like V1. Okay, so let's consider 6 vertices. So this is V1, this is V2, this is V3, this is V4, this is V5 and V6. And how the connection will happen, you can clearly understand that connections will be like this. Here we are interested in minimum spanning tree, so we are directly going to draw minimum spanning tree, and we will always cross check that the edges which we are taking care of, they are obviously existing in the in this graph, whatever the graph is going to be formed by this rule. Okay, now as here we discussed that the smallest one, smallest edge, here also we are going to use Kruskal's algorithm. Okay, so smallest edge is going to be from V1 to V2. Here also that is going to happen. So this is going to be in our minimum spanning tree. Okay, and its edge weight is going to be 3. Next, we know that v1 to v3 will also happen, because 3 minus 1 mod is 2, which is satisfied here, so this will also happen. Now, as here we did not include v3 to v2, which is having edge weight 5, similarly here also it is forming loop. So next smallest edge is going to be from v2 to v4. Okay, and next one is going to be like this is 4 to 6, this edge weight is 6, this edge weight is 4. Okay, next one is going to be from here to here, and this is 8. Okay, so now you are getting the pattern, right? Now next one is going to be v4 to v6. So now we are understanding that, and its edge weight is going to be 10. So we are understanding that this is the general structure in which it is going to be the final spanning tree is going to be like this. So let's decode what is the pattern here. The pattern here is, firstly let's write all the edge weights which are in the minimum spanning tree. Okay, so you see here, right, that okay, 1 2 3 4 5 edges are there, and that is obvious because there are total 6 vertices, and therefore the minimum spanning tree is going to have 5 edges. But the point is that which are the edges included, that will define what is going to be the cost of our minimum spanning tree. So the total cost here is 3 plus 4 plus 6, 8 and 10. Okay, 6, 8 and 10. Now this is not giving us a clear picture. Let's decode it by understanding what is this 3. So this 3 came because we added 1 plus 2, right? So this is basically 1 plus 2. This 4 came how? 1 plus 3. Okay, 6 came from 2 plus 4, right? This 8 came from 3 plus 5, this one, and this 10 came from 4 plus 6, right? 4 to 6. Okay, now understand that what is the pattern which is being followed. See, 1 is 2 times. Okay, so we can say that 2 times 1 is there. Similarly, 2 times 2 is there. See, also 2 times 3 is there. Also 2 times 4 is there. And then 5 and 6 are single times. Okay, so 5 is one time and 6 is also one time. Now we are getting the pattern. So basically 2 times 1 plus 2 plus 3 plus 4, and then 5 and 6 we are having separately. Okay, so 6 edges are there, then this pattern is coming. Now it is coming to light that if n vertices are there, then this pattern can be generalized as 2 times 1 plus 2 plus 3 till obviously n minus 2, and the last two weights are basically n minus 1 and n. Okay, so this is the pattern which is coming. Now we simply have to compute what is its value. So it is going to be basically 2 times n minus 2 into n minus 1 divided by 2 plus n minus 1 plus n, and this is cancelled, and then here we can take n minus 1 common. So it is going to be n minus 1 common, and then we are going to have n minus 2 plus 1, which is basically n minus 1 again. Okay, and plus n. So basically it is turning out to be n minus 1 whole square plus n, which is n square plus 1 minus 2n and plus n, and summing it we get n square minus n plus 1. So this is a general formula. So we see that option B is n square minus n plus 1, and this is the answer. Okay, so the answer is B.